What if I told you that the mayfly, an insect synonymous with brevity and fleeting existence, once ruled ancient waters with lifespans that would make modern mayflies seem like mere blinks of an eye? The discovery of these time-defying creatures challenges everything we understand about evolution, survival, and the nature of life itself. For over 300 million years, mayflies have been Earth's ultimate survivors, but their story is far more complex and extraordinary than we ever imagined. Deep in the fossil record, preserved in stone for millions of years, lies evidence of a world where mayflies were the titans of ancient waterways. These prehistoric giants didn't follow the rules that govern their modern descendants. While today's mayflies emerge from water only to die within hours, their ancient ancestors lived extended lives that allowed them to experience seasons, witness the changing of landscapes, and develop behaviors that their brief-lived modern cousins could never imagine. The implications of this discovery ripple through our understanding of evolution, survival strategies, and the very concept of time in the natural world. These ancient mayflies weren't just surviving longer, they were thriving in ways that challenge our most basic assumptions about insect life. They represent a lost chapter in the history of life on Earth, a time when the rules of existence were written differently, and longevity was not a luxury, but a necessity for survival. The ancient giants that defied time. The fossil record tells a story that paleontologists are still struggling to fully comprehend. Dating back over 320 million years to the Carboniferous period, fossilized remains of mayflies reveal creatures that bore little resemblance to the ephemeral insects we know today. These ancient specimens, preserved in remarkable detail in sedimentary rocks, show clear evidence of extended lifespans that would have allowed them to live through multiple seasons, adapt to changing environments, and develop complex behaviors, impossible for their modern counterparts. During the Paleozoic era, when the Earth's climate was dramatically different and oxygen levels were significantly higher, these prehistoric mayflies evolved in an environment that favored longevity over rapid reproduction. Unlike today's mayflies, which must compress their entire adult existence into a frantic race against time, ancient mayflies had the luxury of extended lifespans that allowed them to develop sophisticated survival strategies. They're fossilized. Wings show evidence of wear patterns consistent with months of flight. Their bodies exhibit growth rings similar to those found in long-lived organisms, and their reproductive organs suggest reproductive cycles that spanned seasons rather than hours. The atmospheric conditions of ancient Earth played a crucial role in supporting these extended lifespans. With oxygen levels reaching up to 35% compared to today's 21%, these prehistoric environments could sustain much larger and more active insects. The higher oxygen content meant that mayflies could maintain their metabolic processes for extended periods without the energy constraints that limit modern species. This oxygen-rich environment was like a performance-enhancing drug for ancient insects, allowing them to break free from the biological limitations that confine their modern descendants. Archaeological evidence from sites across the globe paints a picture of mayflies that were not just surviving, but thriving in diverse environments. From the coal swamps of what is now Pennsylvania to the shallow seas of ancient Europe, these extended-lived mayflies colonized habitats that modern mayflies could never successfully occupy. Their longer lifespans allowed them to develop territorial behaviors, complex mating rituals that could span weeks rather than hours, and the ability to migrate across vast distances following seasonal food sources. The preservation quality of these ancient specimens is nothing short of miraculous. Some fossils show mayflies with intact digestive systems containing fossilized meals, proving that these creatures maintained active feeding throughout their extended adult lives. Modern mayflies, in contrast, often lack functional mouthparts as adults, surviving only on energy stored from their larval stage. This fundamental difference in biology suggests that ancient mayflies were operating under completely different evolutionary pressures and survival strategies. The evolutionary paradox, the transition from months-long lifespans to hours-long existence, represents one of evolution's most puzzling paradoxes. How does a species evolve to live shorter lives? Conventional evolutionary theory suggests that longer lifespans should provide competitive advantages: more time to reproduce, greater opportunity to pass on genes, increased survival of offspring, through extended parental care. Yet somewhere in the vast expanse of evolutionary time, mayflies made the seemingly counterintuitive choice to compress their adult lives into mere hours of existence. The answer lies in understanding the fundamental shift in survival strategy that occurred as Earth's environment changed. As oxygen levels decreased and competition for resources intensified, mayflies faced a crucial evolutionary crossroads. They could either compete directly with other insects for limited resources over extended periods, or they could develop a survival strategy based on overwhelming numbers and perfect timing. Evolution chose the latter, creating one of nature's most spectacular examples of reproductive synchronization. This evolutionary shift wasn't gradual. It was revolutionary. Fossil evidence suggests that the transition from extended lifespans to brief adult lives occurred relatively quickly in geological terms, spanning perhaps only a few million years. This rapid evolutionary change indicates that environmental pressures were so intense that only the most extreme adaptation could ensure survival. The mayflies that survived this transition developed the ability to synchronize their emergence with incredible precision, creating massive swarms that could overwhelm predators and ensure reproductive success despite their individually brief lifespans. The genetic mechanisms underlying this transformation are still being unraveled by modern scientists. Recent studies of mayfly DNA have revealed that the genes controlling longevity in these insects have been dramatically modified over millions of years. Where ancient mayflies possessed complex genetic pathways for cellular repair and maintenance, modern mayflies have essentially deleted these systems, redirecting all energy toward reproduction. It's as if evolution performed genetic surgery, removing everything non-essential to focus entirely on the singular goal of reproduction. This evolutionary strategy, while seemingly extreme, has proven remarkably successful. Modern mayflies have colonized virtually every freshwater habitat on Earth, from Arctic streams to tropical rivers. Their ability to appear in overwhelming numbers has made them a crucial component of aquatic ecosystems, serving as a vital food source for fish, birds, and other wildlife. The sacrifice of individual longevity has been compensated by the incredible success of the species as a whole. The implications of this evolutionary paradox extend far beyond mayflies themselves. It challenges our fundamental assumptions about what constitutes evolutionary success and forces us to reconsider the relationship between individual survival and species survival. The mayfly's evolutionary journey from ancient giants to modern ephemerals represents one of nature's most extreme examples of specialization, where the entire strategy of existence was rebuilt from the ground up. The hidden truth behind modern mayflies. The story of modern mayfly lifespans is far more complex than the simple narrative of brief adult existence. While their winged adult stage may last only hours, the complete mayfly life cycle tells a dramatically different story, one that echoes the extended lifespans of their ancient ancestors. The truth is that modern mayflies do live for months, sometimes even years, but they do so hidden beneath the surface of our streams, rivers, and lakes. The aquatic nymph stage of mayfly development represents the true lifespan of these remarkable insects. During this extended underwater phase, mayfly nymphs exhibit behaviors and survival strategies that would be impossible in their brief adult forms. They establish territories, compete for resources, adapt to seasonal changes, and develop the complex physiological systems that will power their eventual emergence. These underwater mayflies are the true inheritors of their ancient ancestors' longevity, living full and complex lives that unfold over months or even years.